In this particular video, we are just focusing on some three statistics mathematics. First one, we're going to talk about the range, how to find the range in a given array, how to find the range, and then we're going to work with standard deviation, and we have a formula for it. And in the third problem, we're going to solve a very big problem, which is interquartile range. So we're going to first understand the theory, and then we turn to implement it code, so that we can understand the theory first and we have the logic in our brain and we can focus on our main core logic. Okay, so তিনটা জিনিস আমরা ফোকাস করব। ফার্স্ট হচ্ছে থিওরি, দেন আওয়ার লজিক, অ্যান্ড আমাদের ব্রেনটাকে প্রপারলি আমাদের গাইড করব যাতে আমরা এই লজিকগুলো অ্যাকচুয়াল কোডে ইমপ্লিমেন্ট করতে পারি। সো দ্যাট ইজ দ্য থিং উই রিয়েলি ওয়ান্ট। ওকে, সো লেটস গেট স্টার্টেড। ফার্স্ট আমরা রেঞ্জ নিয়ে কাজ করব। এখন রেঞ্জটা কি? রেঞ্জ এখানে আমরা যদি দেখি, হোয়াট ইজ রেঞ্জ? রেঞ্জ ইজ অ্যাকচুয়ালি নাথিং বাট maximum value minus minimum value in a given array. Like I have an array, if I take this one, I have an array which contains 1, 2, 3 and 4 and 5, these 5 elements. So the highest value is which one? As it is as it is sorted by ascending order, এটা আপনারা দেখতে পাচ্ছেন যে এটা হচ্ছে ascending order এ sort করা, so we can easily find এই array এর মধ্যে maximum value হচ্ছে 5, so we're gonna take this 5, okay, and we're gonna do minus the lowest value হচ্ছে 1, this 1 is the lowest value, so we're gonna just do the calculation, 5 minus 1, which is 4, so our range is 4, highest value minus lowest value. And you don't need to have a sorted array for this. You just find which is the highest most value in this particular array and the lowest value, and you just negate it, and 5 minus 1, max value minus mean value, and you get the range. So this is how you're going to get the range. So now we're going to implement this in the code, and then we're going to focus on standard deviation and other stuff, because understanding this main logic is important. So how can you find the highest value in the array and the lowest value in the array? Let's do it into the JavaScript code. So for that we need to understand our range, how to find the range, which is max minus min. Okay, so first we need to take an array, which is our input array, and it can be 1 up to 9. Let's take 10 also. So this is our input array. We need to find the highest value and the lowest value and just minus them. Highest value minus lowest value is actually our range. So we need to build a function called find range. This is how we build the function in JavaScript. So that is super important if you don't know. And I have a tons of video on JavaScript. You can watch my previous video on my YouTube channel as well. I have talked about tons of stuff on that platform. So if we just focus on this find range, you're gonna input at array, and this is your array, and here we're gonna work on something like, first we're gonna console.log this array, and we're gonna call this function find range. মানে আমরা find range ফাংশনটা কল করতেছি এখানে, and আমাদের input arrayটা দিয়ে দিতে হবে, and we're gonna just run this, and this is our input array. This is our result. So we need to find the highest value and the lowest value. So this is the thing that we are getting. So to get the highest value, we need to get the const maximum value. You're going to use a JavaScript inbuilt function called math.max, and that it needs some values as a number, and it should be iterable, like 1, 2, 3, 4. You should give in numbers values as an array format, or you have to spread it. 3 dot operator, which is actually the spread, because it cannot take array. You need to just spread all the number. First it will take 1, 2, 3 up to 10. So this 10 number you're going to compare which is the biggest one. Okay, so we have to use array, this spread operator array, otherwise we will have some problem. Similarly for maximum, we are doing it. For minimum it is similar. For minimum we need to use math.min. Okay, so we're going to get two values, and we're going to return max minus min, and as we are returning something, we need to use console.log and range. range is actually our find range function, and you have to give your input array as this parameter so that we can find these required informations. So if I just run this, and our range is 9 because 10 is the highest value and minimum value is 1, so 10 minus 1 is equals to 9. Okay, and it works for many. If I just turned it to like up to 17, it would be 17 minus 1, which is 16. As you can see, it is 16. So it is very powerful. You can just give it now any number, it will just give you a range. So this is awesome. But if I just don't do this, if I just do normal pass the array, normally people will do that, they will pass the input array here and it will want to find the max of this array. But just look at this console dot, if I just console dot this max value, let me check it out what happens. Max is equals to none, not a number, because it can't iterate over it. Okay, it can't iterate over it. So if I just console dot log here array, and I'm gonna console dot log our new array that is iterable, and triple dot array or spread operator array. So I want to show you the difference. The new array is just normal array, we don't see any array sign, but in the beginning we see this array. As you can see, the square bracket, it means that it is an array. But the new one, console.log new array, এই জিনিসটা কিন্তু আমরা দেখতেছি এটা একটা নাম্বার কনভার্ট হয়েছে 1 2 3 4 5 6 7 8 9. It is not an array, it is an iterable numbers. And iterable numbers, if you give it an iterable number, then it will give you an awesome information that what is the max of the among those numbers. So what is the maximum value of these numbers when you convert it into iterables. Otherwise, when you give information to the max, this information takes iterables. As you can see, spread operator to spread all the numbers from an array. It can't operate on array directly, you have to spread it. So you have to use this thing. So that is the reason why I'm showing you this thing. Without this thing, you can't work with this. So one programming language, if you want to understand JavaScript properly, this is the thing how you have to understand JavaScript first and solve some programming problem and understand some logic behind it, why it is working like. So standard deviation, there is this very awesome formula which is summation of xi minus x bar whole square divided by n minus 1. Normally it's the formula is like that, but for programming cases you can negate this minus 1. It is all up to you, but this is the actual formula, and you need to use the root over of all the calculation you have done inside it. এটার ভিতরে আপনি যতগুলা ক্যালকুলেশন করছেন সবগুলা ক্যালকুলেশন করার পরে এর নাম্বার অফ আইটেমস দিয়ে আপনার যদি এটাকে ভাগ করে দেন বা ফাইন্ড দি টোটাল, এটা হচ্ছে আমাদের সাম, ঠিক আছে, সাম ডিভাইডেড বাই টোটাল নাম্বার হুইচ ইজ অ্যাকচুয়ালি দ্য অ্যাভারেজ মিন। এটা হচ্ছে কোভেরিয়েন্স বের হয় ভিতরে যে জিনিসটা, এটা হচ্ছে কোভেরিয়েন্স। এটাকে স্কোয়ার রুট করলে হচ্ছে স্ট্যান্ডার্ড ডেভিয়েশন। স্ট্যান্ডার্ড ডেভিয়েশন হচ্ছে, ধরেন আমি এখানে একটা ভ্যালু দিলাম লাইক 1 2 3 4 5 and like 4 5, ওকে। অ্যান্ড এটার মিন হচ্ছে 1 থেকে 5 পর্যন্ত যদি আমি যোগ করি 2 3 4 plus 5 5 times 5 plus 4 9 12 and 14 and 15. So 15 is the summation of all the numbers divided by total numbers, which is 3. So our mean value is 3. Okay, our mean value is 3. This is our mean. And what is the difference between mean and all the corresponding values? From 1 to 3, the difference is like 2. From 3 to 5, if I just compare 3 to 5, the difference is only 2. And from 2 to 3, the difference is 1. From 3 to 4, the difference is 1. Okay, so this is the difference from the mean to all the value. The average distance is the thing that we want to find out, and we need to find out how much closer they are. ওই ভ্যালুগুলো কতটা ক্লোজার, লাইক 4 এবং 5 3 এর কতটা কাছে। একটা হচ্ছে 1 ডিস্টেন্স দূরে, একটা হচ্ছে 2 ডিস্টেন্স দূরে ভ্যালু হিসেবে কম্পেয়ার করলে। আরেকটা হচ্ছে ভ্যালু হচ্ছে 2 এবং 1 3 এর আগে। এই দুটা স্মলার ভ্যালু, the first one difference is 2 and the second one difference is only 1. So this is the difference between them. If it was like a range of 1 50 and 30, and the mean would be 81 divided by 3, if we just calculate 81 divided by 3, like let's check it, divided by 3, which is 27. So which is 27. So 27 is our mean value. In that case, how much they are different. Okay, so if for this one it is 27 times higher, and for this is close to 27, close to 27, and this is very far compared to the 50. So 27 is actually, this is our average value, average standard, this is our average value or the mean value. So how much distance is it is from 1, how much distance is from 30. If some values has like, if you add one more input, 60, and see how much the difference is. Now the standard deviation is very higher, because your difference from this mean to your last index value is very higher. Okay, so that is the thing that I wanted to show you guys. It is very high. On the other hand, if we use 1, 2, 3, 4 and 5, and this is the mean value, and the difference is very small, it means that all the values are very closer to each other. But if I use this formula, like 2, 8, 16 and like 32 and 64, and then see the difference is very high. The difference is 6, and then we have 8 difference. If I see there are 8 difference, and in the beginning it is 6 difference, and then we have it means that all the values are very far from each other. There are 16 difference, it is 32 difference, so they are far from each other. So standard deviation is much higher compared to this one. Okay, much higher. So that is the thing that is super important to understand. So standard deviation হচ্ছে আপনার data science, machine learning, or any other programming fields, or any machine learning, artificial intelligence, you have to understand the statistics, mathematics, and you have to apply it into your Python code as well. But here I'm going to show you how we are calculating it properly. We are doing it as a programmatic way. We're going to give some input values, and it will give us what is the information we need. First, in the first step, what we need, we have to find the mean. We'll be given some input samples. We're going to find the mean of all the values. We're going to find the mean. And the second step, we need to work on our like sum the squared of the differences. Xi means each individual value in the array. You're going to get each individual value minus the mean value and sum them up. And you need to do it for all the values. That's why we need to sum this up, like 1 minus 2 square plus 2 minus 3 whole square plus 3 minus 4 whole square. Okay, and the total number of items. So this is how we're gonna sum them up, add all them up, the difference of all the values and their square. So this is the difference square. Okay, summation of their difference square. We need to find this out. This is the second step, and then we're gonna find the mean of their difference as again, which is again finding the difference, but for these values. So when we understand the code, you will find it much better. So then we need to find out the sum of square difference. It means that xi minus x bar whole square difference. This is the thing that we're going to find. And covariance is nothing but just a simple summation of all the values, xi minus x bar whole square divided by n. We need to divide it by total sum divided by total number of items in the array or the items. Then we can take the covariance, and the fourth step we're going to find the standard deviation, which is the root over of all of this stuff. Okay, nums array should be 1, 2, 3 up to 10. Let me add up to 10, which is much better. And for better understanding, I'm going to keep it up to 5. Okay, so that you can understand it better. And add some spaces. Okay, so we need to make a function again as usual. So const find standard deviation. You're going to take an array as an input, and we're going to call this find standard deviation, and we're going to pass the numbers of array. We are just calling this. Okay, And then this is our main function how we're going to do all this stuff. First one is step 1 is to find the mean. So const mean is equals to, here we need to array dot reduce function. This is a higher order function that takes another function and it takes current value and current index number and all of this stuff. So basically what it takes like a and I. Normally we take an a and I, but here for better readability I'm going to use the sum, which is the accumulator, and the number we need to add. What is going to do, it will take each individual value in the items in this particular array, and we need to just sum them up. So that's why the reduce is useful for any operations in the, suppose we have an array of object, you need to get all the users data, user's salary, and you need to sum them up. You can easily do this. So how can you do this? Sum plus the number. So first number 1 is coming into this, and add this to the sum, and your total sum should be 1, suppose 1. Then it will again add, now the total sum is 1, and need to add number 2, which is 2. So total now is 3. So 3 value, and then third iteration it would be sum would be 3 plus that again the fourth number, which is 7, fourth number which is 4, so total would be 7, and then next iteration it would be like 7 plus 5, this stuff. So basically what we do is just simple. It is just gonna add all this stuff. First this one, then the total this one plus which is 3, and 3 plus 3 which is actually 6. Okay, 6, and then you're gonna add 4 which is actually 10, and then 5, which total is 15. However you understand it, it's simple. And then it's gonna start with 0. Then what we need one more stuff. This is the way we're gonna get all the sum, all the information. So if I just console.log this mean, if I just console.log this mean and just call this, we get 15, but we need to divide it by 2. But we need to divide it by the total number of values in the array. So how can you find it? Array.length. So this is how we're gonna get it. So if I just do this, we get 3. So total number, if I sum them, is 15 divided by number of items, which is 5. So 15. So what it does, if 15 divided by 3, 15 divided by total number is 5, which is like 3. Okay, so this is the 3 that we are getting. Simple mathematics, very simple method. Okay, so it is completely dynamic. It will check how much length you have in your array, how many numbers are there inside the array. It will do it automatically. So our first step is done. So our step 2. Now our step 2 is very simple stuff again. So here what we have to do, we have to find the square difference, sum of all the square difference of these values, the square differences. So how can we do this? We have to iterate over this array again. So array.map, this is how we can array this. This is another higher order function where we can use the map so that we can just map all the informations and do some operations with it. We can do filter as well, but here the map is the, we can do like array for each loop here, but here I think the array.map would be really nice. And in React application for rendering dynamic content and for looping through any array of object, we're gonna use this array.map a lot, so it would be a better practice to do this. So it is another it is another header function. That's why it takes another callback function that takes some value, index number, whatever. It takes value, it takes index number of this item. We can do this stuff. But here I'm gonna take it like a simple num. Okay, a simple number. You're gonna give some number, and here we're gonna do const difference is equals to, we're gonna get each individual number with xi minus its mean. So this is the thing we want. Okay, so so we are mapping array, and we're gonna getting each individual number minus its mean, and this is the same stuff we have to do, and then we need to square it as well, and then we need to add them up, sum them up. So this is the stuff, and we need to return the div times div. This is how you're gonna square in our programming language. So this is how we do. So if I just console.log this square divs, what we're gonna get, So if I just run this, so square difference, this is the square difference 410. So this is 410. So let me show you this thing. So our input is 1 2 3 4 and 5. So this is our input. So first square difference is our mean is 3, so 1 minus 3 our difference, and if we square them up so that we don't have any negative value as well, it will negate everything because standard deviation cannot be negative, and it is minus 2 square, which is 4. So it is working really nice for value 2. Minus 3 is the mean, and if we square them up it would be like minus 1 square, which is 1. So it is working really fine. So our total answer will be 41014. Nice, beautiful. Now what we have done, we have done this part. We have done this part. Now we need to add all them up. Add all them up because we have to, it has a summation sign. Then we do all them up divided by total numbers of the array inputs. So this is super important. So that's why we have logged this. And now step 3 is what we call in this statistics field a covariance. Now covariance, so this is the thing we need. Const, so we need to find, it should be variance, not covariance. So if I want to find the variance, it should be all the square divs. We need to go inside square divs, so we have all the values inside this array, and we need to go and just sum all of the sum divided by total number, and we need to use reduce again, and inside the reduce we're going to use now sum and the value, whatever the value you got, and sum plus whatever the value you got, and like whatever first is 4, it's gonna add it with 4, and then 0 with 4 you're gonna add, which is 4 plus, then 4 plus 1, which is 5. Then you're gonna incrementally adding all the informations in this array, all the values. So this is what I have done. And divide, you have to divide it by the number of items in this, which is 4. 0 1 2 3 4 5. So how many numbers we in the square diffs array we have? 4 1 0 1 4, which is total 5 numbers. So it's length, so we're gonna get this length, total sum of all the values, the square difference divided by total numbers we have. So that is the variance. You can also add minus 1 as the formula suggests, but you can also skip this part. So if I just console.log the variance here, তো এখানে আপনারা দেখতে পাবেন. So what is the variance here? If I just log this out, beautiful. So our variance হচ্ছে 2. Our variance is 2. The difference, the sum of the square difference is actually 2 from the mean. Okay, so if, and then we have to square root all of them, then we can find the standard deviation. So standard deviation, if you want to find it, we need to map dot square root. So this is how we're going to square root using the JavaScript programming language, and we need to find the variance here. So if I just console.log this standard deviation, you're going to find this standard deviation. So standard deviation is 1.41. This is the standard deviation we got. But if we just increase the value to up to 6 to 10, then let's check it out. Then we got the value 2.87. So here we can console.log mean, and we need to check it out. So our mean is 5.5. As expected, I have also showed you this inside the calculator. It is mean should be 5.5 if you will increase your number to up to 10. And then the variance is also increased because we are just taking each individual number in the array, and we're gonna negate it with the mean value, and that is how you're gonna find the difference. And then we need to return as a square, so difference times square, and then this is the square difference, and then the variance is the number of items in the square difference array and with its length, and they're going to get the variance. The variance is 8.5, and then you have the standard deviation 2.87. So our mean is 5.5. It means that all the values in this array are almost from the mean are close to 2.87 value. Like our mean is 5.5, something like here, and all the values are close to this. For average, if we just take 2, it is very close to 2.7. If 2.87, if you add like 2.87 2 plus 2.87, it is almost 5.5. okay, almost 5.5 if we just add those two out, almost 5 on average. And if I take 3, then it is like distance from 3. If I want to reach up to like 5.5, how many values we need to add? Like 2.5 we need to add to reach into this. So this is the standard deviation, and this is our actual value input, each individual number, and 5.5 is our mean, and how much difference is 2.5. so this is our difference, the standard deviations. So 2.87 is the average standard deviation between the mean and all the individual inputs that we have. From 5.5 you need to calculate how much distance is, how much far is like 8, how much far is 10, how much far is 1 from 5.5, how much far is 2 from 5.5. The average distance is, the standard deviation is 2.87. So 2.87 is a very small standard deviation. If I add like 100 here, let me check what happens here. So see, standard deviation increases hugely because 100 is so far, and then our mean also changes, because mean changes if you add a higher outlier like 100, 1000, then mean would go into the right side. So our mean changes up to 14, and variance also increases significantly. And then our standard deviation is 27 because now we have added a huge value, so mean is shifted to the right side. Before that it was like that, but now it is like here inside this. So our mean is changing, so mean changed from this position to this position. So now our standard deviation is higher because the difference between the mean and all the individual value is higher now. Those values like 300, like 500, it means that it is spreading so far compared to the mean, so our standard deviation would be higher. So it is spreading too much, these values are not inside the center, it is spreading too much, it is not near the mean, the value is going very very far, it is not close to this. If the standard deviation is smaller, all the values will be close to this here. So it is a good for machine learning algorithm to data analysis. If your value is close to mean, it means that you can group it as well in a single classification, like cancer cell detection or any disease detection or any heart disease detection. If all the values are closest to this, it means that they are in a single group and they are in another group. Okay, so this is how in the machine learning also works. So programming, mathematics, and all the everything is very very connected, well connected. But now our standard deviation is very higher if we add this outlier like 100, 500, 700, 600. The standard deviation goes to so higher. Okay, so it means that you are not in this class, you are here. So the mean is also changes, the standard deviation changes. It is not good for our data analysis or statistics. It is not that good sign. So you have to understand what the standard deviation, what the mean, all of this stuff, programming, and it works. And why we need programming, because it can give you all the scenarios. Like I cannot do this in my own hand, just find each individual value and calculate the mean sum and add the square of this is the mean sum, and they're gonna find the variance separately for all the values and the mean. It is very hectic, we can't do that. That's why the programming is super important, and we have to understand why it is so vital in our programming languages. But in this particular program, I'm not going to talk about the complexity analysis because we have added tons of higher order functions, and based on this number, it can be it is order of n, and this is, if you want to reduce, it is order of n. So ultimately it is order of n. Okay, so ultimately it should be order of n if we just do all this stuff. In the next program, which is actually our finding the interquartile range, so we're gonna name it interquartile range. Interquartile range is this difference between Q3 minus Q1. This is the difference of interquartile range. Now how you gonna calculate it? Okay, so let me take an array, and in this program we're gonna solve every single thing with time complexity analysis, so that you can get the full understanding of how the algorithm works, how program works, and how actually the interquartile range works here. So if I just now take an input array like 1, 2, 3, 4, 5, and we have total 5 elements, which is odd number, and 3 here is the or median. This is not mean and median is not same, so this is median. median is the actual mid value of an array or given inputs. And this is a 1D matrix, it can be 2D matrix or any other stuff, but 3 is the actual mid value, and there are 2 values on the left, 2 values on the right, so actual mid value. So if you have an odd number of information here, actual mid value is actually your Q2. We're gonna call it quartile 2. Then how can we find the quartile of 1 and quartile 3? That is the reason we have to do this programmatically. We need to make sure we have the algorithm and we understand this algorithm deep in our heart. So just divide it into 2 parts, this part and this part. So 1 and 2 and 4 and 5. Now what is the midpoint of this? There are 2 values. We cannot take 1 or 2. We have to take, if there are even number, so if there are even number of values, we need to add all of this stuff, 1 plus 2, add those 2 numbers in the array divided by their number of items in this subarray, which is array.length, which is 2. So we're gonna get 3 divided by 2, which is 1.5. Okay, so 1.5 is our median, and here our median should be, if I just use another one, 4 plus 5 divided by 2, because there are only 2 information. If there are like 3 information, 1, 2 and 3, we could have taken the middle one, 2, which is the median, but we can't do this here. There are only 2 information in these 2 items in this array, or 2 numbers in this array, so we need to sum them up and divide it by number of items in this particular subarray. So which is 4 plus 5, which is 9 divided by 2, which is 4.5. This one is actually our median, which is Q3. The information, the median we are getting from the right subarray, which is 4.5, actually the Q3, which is the median of this right subarray. This is actually the Q3, and 1.5 is the median of the left subarray, and the median we are not considering here because we are dividing the array into 2 information, like 1, 2 in the left and 4, 5 on the right. So 1.5 is the lowest value, which is the Q1, and Q3 is would be the higher value. And in the mid value, we have the actual mid of this full array. Median is Q2. So we need to get Q3 minus Q1, which is here, which is 4.5 minus 1.5. So see how many steps we have. First we have a long array, then we have we have gotten the median, actual median and the mid value if there are odd number of information. Okay, so that is the thing that we need to focus really on, that how we can implement this feature. Okay, so we have to solve the edge cases. If there is 6, then we have to do this again. We have to solve this in a different way. Okay, so we need to just think how we're gonna do this. First we are gonna define the median. This is the actual mid, which is the Q2, and then we need to find the Q3, and for that, for Q3 you need to divide it into right subarray, and here we're gonna find mid again, and we're gonna find this Q3, and then we go into the left subarray, and we're gonna find this Q1, because we need to get the mid value and the mid value, and if we just subtract Q1 from Q3, you're gonna get the interquartile range IR easily. So finding the mid value and slicing them into different 2 subarrays and finding the mid value of them. So these are the steps that we really need to follow. So we need to be really careful in the programming language how we are doing it, and we need to also check out the odd values and even values. আমরা odd value এবং even valueটাকে কিভাবে compare করতে পারি? Like if we have odd values in the beginning, if we have like even number of values 4, 5, this was odd and this was even. So even then if we take these 3, there if we total 3 and 3, total 6 items in this array. And here if we want to take the mean value, we cannot take it because If I take 4, there are only 2 values on the right and 3 values on the left. If I take 3, there are 3 values on the right, 2 values on the left. We cannot do this. We need to take the centermost values and sum them up and find the mean. So 3 plus 4 divided by 2, which is 7 divided by 2, which is 3.5. So our actual mid or median value, which is the Q2, would be 3.5 here. So 1, 2, 3.5 would be our actual median, and we need to take 5 and 6. Okay, 5 and 6. Then we are dividing it properly. Then we need to take only these two, so that's why we need slicing. In the JavaScript we have a slice, and so for the right part we need to slice it. First we need to take it up to mid index, and then we're going to slice it mid index plus 1, because we don't need this. We need to take these two subarrays, and then so that we can get these two subarrays. Basically we are taking an odd number of items 1 up to 9, so that we can actually divide it the Q2. We can find the Q2 easily. Q2 would be 5, because there are 4 elements on the right and 4 elements on the left. We can directly get the median, which is our Q2. We need to get that thing anyhow, and then we need to separate it based on two information like 6, 7, 8, 9 and 1, 2, 4, 5. Okay, so we're gonna build this function, find interquartile range, and here we're going to use an array function, and we're going to call this thing interquartile range, and we're going to give this numbers of array, and here we're going to take this array as an input. Okay, the value should be sorted, otherwise you won't find this, because 6, 7, 8, 9, 10 is very higher value. You will find Q3 here if you take the mid, and if you take 1 up to 4, and if you find the mid, you will find the Q1. So there you have to understand this very well. So first we're going to solve this. If the array dot length is equals to 0, we're going to return nothing, or you can return 0. And then this is our cases, so that if the array returns is 0, then we have to return nothing. Then you have to make sure our each individual number of array items should be sorted. It should be sorted. So let's sort it. Sorted array is equals to, if I take the input array and spread them, so we have to spread it, and then we need to sort them out. So this is JavaScript function that takes two information, property A and B, and compared them, and if you return A minus B. If you want to do it for ascending order, if you want to do it for descending order, it would be like B minus A. Okay, so for descending, and now we're doing it for ascending order, so lowest value up to the highest value. This is the thing that we need. And if we just console.log this sorted array, so let's check it out. See, 1 up to 9, this is our sorted array. Even it is not sorted, if I just add like 0 here and add 12 here, let's check what happens. So first we have the 0, and then we just sort it. So it is working really fine, so no issues. Okay, so now this is our main functions, or the main array. Okay, so first what we have to do, we need to get the mid index, mid value and index. So both of the things are very essential. So in array we are working with the index value. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8. So total 8 index, and total numbers of items is 9. So we have to make sure you're gonna get the mid. So const mid index is, we need to divide the whole array into two parts, like sorted array dot length divided by 2. So we need to get this information. So if we want to get console.log and mid index, so we can easily get this mid index here if I just made this one. So mid index is 4.5. So you should understand why it is like that. 4.5 is like 0, 1, 2, 3, and the index cannot be like decimal points, so we have to convert it into like floor. So we need to use math.floor, and this is how we need to do this. So now if I just convert it, it should be 4, not 4.5. So we need to take the floor value. If we take in the sale value, it will take the 4.5, it will consider it as 5, so we don't want that. We have to use 4 for this particular algorithm because we have to find the mid value. This is our step number 1. We have to find this mid value. So like that, each individual cases we if I zoom out, we had to find the mid value. And if I index, this is 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4 index, so this is 2 index. So in that case the index number 2 is super important. But if I had 10 value, so 9 value, this 1 2 3 4 5 6 7 8 9, if I just this is our adult length divided by 2, we get 4 index. This is our index value. So our index would be 0 1 2 3 4. So this is our actual mid value. Okay, so how can we console.log this out? Mid value, how can you get this information? So we have the sorted array, and here in the index we need to access the mid index of 4. So 0 1 2 3 4, so 5 would be printed. So this is our actual median value, actual mid value, which is 4. This is our index and our value. It will be different because index is 1 less than the value number. Like here we have 9 numbers, but our index is 8, so index would be 1 less always. Here our mid value is 5. We already got it. Now we need to separate the 6 up to 9 and separate the 1 up to 4. So this is what we have to do this. So for that we can take left array and left array and right array. We can separate them easily, left array and right array. We can name it left sub array. It would be a better name because our actual array is sorted array. This is our actual array that we have passed here, and we sorted this out. And then we have to, step number 2 is separate 2 arrays for finding we want q1 and q3. So we need to separate into 2 different half with slicing. আমাদের slice করতে হবে, slice না করলে we cannot find it without slicing. We have to use JavaScript slice if you want to divide it into 2 different array now. So 1 up to 2 3 4 5 6 7 8 9. So we have to divide it. This is our actual mid value. We are separating 1 to 4 and 6 to 9. So this is the thing we are doing it here. It should be sorted array. We need to get the sorted array. Anyhow, this is our sorted array, and sorted array dot slice. It is slice. It takes 2 information. First one, the start number, where you're gonna start to slice it, and the ending number. And the ending number is not included. Like if I start with 0 to our mid index. So let's check. If I console.log this out, left sub array. So if I want to check this out, left sub array 1 up to 4. So we don't have 5. So this is perfect. It is working really nice. It is going up to mid index. Mid index is like 5. Mid index point to 5. So this is how we're gonna get the mid value. But it is not going to the mid index 5. If I get this mid index 5, that it would have printed 5 here. But no, it is not inclusive, it is exclusive. If I add mid index plus 1, then it will take the 5 up to 5. So if I just run this, now it is working. Now it is also including our actual mid, which we don't want. So that's why you can also negate this. I'm just showing you so that you can understand the core logic here, how the slice is working, because this is super important if you want to understand in JavaScript programming or understanding any problem solving interview questions or understanding anything as an algorithm expert. You have to understand why it is working like that, and you have to debug it like that. Okay, so 1 out of 5. This is our left subarray. Similarly, we're going to do it for the right subarray, and instead of right, we're going to name it right subarray. Okay, and it should be right subarray. Okay, and now we have to slice it. Like they are same at this moment because we didn't slice the right index or the right subarray. So right subarray would be starting from, this is our mid index, which is index number 4. We already know index number 4, and it will start from index plus 1, which is 6, which will point to 6. This is index 4, this is index 5, so index plus 1 up to ending. So we have to start from index plus 1 up to ending. So like, how can we get the sorted array dot length? So let me check it out. So 6, 7, 8, 9. So 5 is not included here, so it is working awesomely. But now the problem would be like that. Our sub array are 1 up to 4, but there are even elements 1 up to 4. Okay, as it is an even number 1, 2, 3, and 4. So we need to get this is an even number. So that's the problem we have. We cannot take the mid value easily. We have to use 2 plus 3 divided by 2, which is like 5 divided by 2, 2.5 is our Q1 here. Okay, 2.5 should be our Q1 here. And for this one, for this 6 up to 9, for 6 up to 9, if I just calculate 6, 7, 8, and 9, we need to get 7 plus 8 divided by 2, which is 15 by 2, which is 7.5. So our ultimate answer is, this is our Q3. So our Q3 is 7.5 minus 2.5. Okay, so if I better calculations, I'm going to use a calculator so that we don't get any kind of mistake in our calculation, which is 5. So our interquartile range should be 5 here very easily. So this is the thing we must do here. Or find the mid value of left and right sub arrays. Okay, so for that I'm gonna need a Q1, which will hold the mid value of left sub array, which is find mid value of left sub array. Find mid value of left sub array. Here we're gonna pass the left sub array as an input, and for let Q3, and for Q3 we're gonna do the same thing, but we're gonna get the information from the right sub array. But we haven't built this function, so we have to build this function on the top and const this function that will take an array as an input, sub array, and then we're gonna work with it. Okay, so here we need to work with it. So here we need to get the mid index again. So how can we get the mid index? We need to get the sub array. We need to get the sub array dot length, divided by 2, and we need to use math dot floor. Okay, math dot floor divided by 2, and here if we just console dot log this, found mid index is equal to mid index, found mid index. So let's check this out, guys. So here, as we have seen, this is our mid index is 2 now. Our find mid value, this is our mid index. Actually mid index, we just divided this sub array and like sub array dot length divided by 2. So if we have 4, this is our length, this is our left sub array 1 up to 4. So let's understand what we are doing here. If I just consider 1, 2, 3, 4. Okay, here we are getting the index value, which is 0, 1, 2, which is 3. Also we need its previous value, which is n minus 1, also mid index minus 1. So we have to make sure we work on this. Okay, so if we have if I have some like even number, it would be different, and for odd number it would be different. It is very different. It is not the same. So we have to make sure we work on this thing again. So if we just go into our code, if the sub array, if we just write if sub array dot length, okay, if sub array dot length, if we just %2 is equals to 0, if we just mod this out, it means that the sub array length is 0 up to 4, which is 4 items in this left sub array. if it is divisible by 2, if it is divisible by 2, it means that if I divide it with 2, it is 0. You can divide it very easily. It will not give you a decimal value. So if it is completely properly divisible by 2, then it is like there are even numbers in this left subarray. So in that case, we need to consider this mid index and its previous index as well. So how can we get this mid index and its previous index? Well, we can easily get this subarray. We're gonna get this mid index and add this value with a subarray and mid index not +1, -1, because in the mid index we are already getting the value 2 as this mid index. It should be index. It is not value. It is mid index 2. We're getting the 2. So 0, 1, 2. But we need to get its previous because we need to combine those two and divide it by 2. Okay, so that's the thing. We need to get its previous index. So what I'm talking about here, 1, 2, 3, and 4. We are getting the index number 0. This is 0, 1, 2. But 3 is not. 3 will not cut it because this is actually not the mid. We also take this 2 because there are even number. We need to take middle 2 information, so it's previous one. So 2 is actually our mid index that we already got it, as you can see, mid index 2. Also we need this previous one, which is mid index minus mid index -1. So this is the 2 information. We need mid index and mid index -1, and we need to sum them up. So this is the thing that we need. We need to sum them and we need to divide them by 2 so that we can get the actual value, median value. We need to divide it by 2. Okay, so else we're gonna return this same thing but with a little bit of difference here. We don't need this previous value. We're just gonna get the mid index and divide it by 2. Like in this case, if we have a left subarray, we have 1, 2, 3, 4, 5 elements, then this 3 should be our mid value. Then we don't need to. We just add all this stuff. We have 5 items divided by 2, which will give me 2.5, and if we float it, it will give you 2 index. So 0, 0, 1, 2. So 3 would be our actual mid value. So we don't need to add its value, mid index value, with this previous mid index value. We don't need. We just need the mid index value. So that is the thing that we are considering. If there are odd numbers, we don't need to add this between numbers like 2 and 3. We don't need to combine them. So this is how we're gonna get 3, and how you're gonna get this previous number, mid index -1. This is how we're gonna get the previous index, and also then we can add all this stuff, 2 plus 3 divided by number of items, which is 2 items. So nice. If it is odd, if it is even, because it is modulus 2 is equals to 0, it means that we can divide it by 2 and it would give you an integer number, not decimal. So it is be perfectly divisible by 2. Okay, so that is the logic here. So we're gonna do this for the left subarray, and for the right subarray we need to do the same stuff. This code will work just fine. This would for any array, left subarray or right subarray, it will work just fine. And if I just console.log this q1 and is q1 and console.log q3, so let's check it out what happens there. It should be find mid value of subarray, and you just pass the array. It shouldn't be like left or right. It will do for any subarray. Okay, so this should be the perfect answer. And if I just run this, we're gonna get 2.5 and 7.5. This is exactly the same value that we have given. This is the 7.5 we got as a q3, and in the lower subarray, or the minimum subarray that we have 1 up to 4, this is the lower part. In the lower or the left subarray, this is the left subarray, we got 2.5, which is actually q1, and the next one, which is the higher value 6 to 9, we got 7.5. So ultimately, if we just negate 2.5 from the 7.5, we get 5. So 5 should be our ultimate answer here. So that is the way we're gonna get it, and you're gonna return some result, and you can get console.log should be q3 q3 minus q1. So if I just run this, it is result is equal to 5. This is simple mathematics. You can do it easily, but I'm just logging it each and every line so that you can understand the flow, how it is working. First, you're gonna find the actual mid index, and our mid value should be +1, which is one value greater than this. Our index value 4, 0, 1, 2, 3, 4, but our actual value is 5. So that is the thing I wanted to show. And then we have to divide it with the slice with the left subarray and the right subarray, so that we can find the q1 in the left subarray and the q3 on the right subarray. So that is one main algorithm. So how can you find the left subarray and find the q1, and also you can find the q3 and find the mid value of the in order to find the q3, you need to just slice it from left subarray and the right subarray. From the right subarray you're gonna get the q3, from the left subarray you're gonna get the q1. So we have to make this easily. And also the edge cases we have solved, if there are odd numbers, we don't need to just add this middle two index, mid index and mid index +1 divided by 2. We don't need to do that, or just simply get the mid index of this subarray divided by 2. That is all the thing that we need. This is actually the value we need. If there are 10 elements, 1, 2, 3 and 10, now there are 10 elements. So how are we gonna divide it? Okay, so how we need to slice it. So that's the most important part, how we can slice it properly. So let's check it out, how we can slice it. So if I just show you the Excel graph here, but for if our value is 10, it will not work. Okay, so if I just run this, see, we cannot do this very easily, because it is now left subarray is 1 up to 5, and then we have 6 up to 10. Now it is not divided properly. In the left subarray we should have 5 elements, and the right subarray we should have 5 elements. So where is the other element? We should divide it properly, 5 and 5. This is the left subarray, this should be our left subarray, this should be our right subarray. There are total 5 elements and there are total 5 elements. So how can we do this? So if I get the index value, mid index value, this is our 5 is actually mid index value, which is 0, 1, 2, 3, 4 and 5. 6 is our mid index value. So it is dividing it by this. This is the right and this is the left. So it will not work. So anyhow, we have to get it. This is our mid index, which is 5. This is 5 minus 1. We have to take it mid index minus 1. Okay, so our logic should be different here. If I just comment it out, our logic should be different. So let's do it for if sorted array dot length, and it is divisible by 2. It means that there are even numbers in this our main array. There are now 10 even number. Then we're gonna do it like this, and for else we're gonna do it like this. So then it will work like this, and our left subarray would be like this, and our right subarray would be like this. We don't need console.log here. Oh, okay, so else part is as it is, because it is odd numbers of int values in array, or the main array for slicing. This is the important part, how you're gonna slice it. But now we're gonna work it for the even numbers of elements. So how can we do this? So we can copy these two things and paste it here. Our slicing technology or slicing algorithm would be different. It goes up to 0 to mid index, which is 0. Previous value it was like 0 up to 4, but now we have added one more item. So our index 0, 1, 2, 3, 4, 5, 6 is our mid index. So it should go mid index minus 1, which is 5. It should take 5. And if I just console.log this out, now left sub array in even number, left sub array, let's check it out. Okay, so left subarray in even number 1 up to 5. So it is divided into left subarray. Our left subarray is 5. Now we need 6 up to 10. So how can we do this? We need mid index is 6. Mid index is 5, which means the value 6. So we need to include this mid index as well. So if I just write mid index here up to all the value, so if I just write subarray, then we need to just console.log write subarray, and should be write subarray. So let's check it out. So 1 up to 5 and 6, 7, 8, 9, 10. So it is divided properly now. Okay, mid index up to the value, or you can write mid index up to like sorted array dot length. I think it would be similar, and sorted array dot length if it is even. So it is perfectly working, or you can say this is the shorthand to do this. Okay, now we are separating it to two different values, like 1 to 5 in one slice and 6 to 10 in one slice, and then it should work just fine. Okay, if I just remove this, Q3 is showing none values and Q3 is showing none values. So we can take the help of Gemini. So Gemini AI, we can take AI, and I'm gonna give me the error non solution for this code. So if I just copy this thing, let me check if it is working or not. So we're gonna comment it out and we're gonna paste this. It will solve if there is any problem with the none values, and our code is similar. If I just run this, yeah, now it is working really nice. There are no problem with mid index or any values. Console.log interquartile range IR is equals to Q3 minus Q1. Let's check it, which is interquartile range is 5. So let's check what's the issue with that. 1 2 3 4 5 6 7 8 9 10. Okay, so it is taking two different part, and the first part in the this is the our Q1, and here 8 is our Q3. So 8 minus 3, so 8 minus 3, which is 5 interquartile range. It is working really fine. So it is beautiful. It is working for any number. So if we just add 12 here, it means that now our 6 should be our mid value, and this should be our array. This is our left sub array, this should be a right sub array, because there are now odd number of elements in this array. Now as you can see, it is sorted. This is our Q3 is 9. So let's check it is actually Q3 is actually 9. It is 1 up to 6, and then this is 9, and then we have 5 to 6. This should be, yes, it should work. It should work just fine. 3 9, and our interquartile range is 6. So I think it will work for both the cases. It works just fine. Now let's understand the time complexity analysis. So time complexity analysis. Now time complexity analysis is a very important topic. Now if for any programming language, for any core algorithm or data structure, understanding this time complexity analysis is super important. So first one, for sort, first we had to sort this. But before that we had to get the array as an input. So this copying of this array, it takes O of n. Then plus, you're gonna add all those stuff. Then we have done the sorting. So here we have done the sorting here. Here we have done the sorting of this array because it should be sorted. If otherwise we can find the interquartile range. For sorting, normally the base cases is n log n. If we understand any sorting algorithm, this is the algorithm. This is the complexity of it. because sorting is actually divide and conquer method that actually uses the log n, and for n numbers is the number of items we need to iterate for each of them, so that's why n log n. Plus we have used our mid index, and for that we have also used divided by 2. We need to, for mid index finding, we need to use O of n by 2. So O of n by 2, which is actually O of n, you can write it. And then we have found the slicing. For slicing, it would be, we are dividing into 2 different parts, 0 to mid index and the mid index up to the final index. So it is also order of, so it is also the order of n by 2, because we are dividing and chunking it to 2 different parts, left and right side. And similar for this, and then we have called another function that gives us the mid value, and we just subtracted this, which is order of 1. And for find the mid value, q1 q2, this is order of, if we want to find the q1 and q2, this is again taking another sub array and dividing by 2. This is order of n by 2, order of n by 2 again, and to get the q1 and q3 value, which is actually the subtractions between those 2 value, q1 and q2, this is order of 1. So if we add all of this stuff, so order of n is the most prominent one, and you can also name it similar. We can negate this thing, we don't need this stuff, and we don't need this stuff because this doesn't matter. It is almost the same. Order of n by 2, n by 3 is almost similar to order of n, but here we have log n, so we need to calculate it, n log n, so they are different. So our total, so this should be our final answer, order of n. And then we have used the divide and conquer for sorting, for slicing, which is for sorting, which is n log n. And basically these are the 2 stuff that we need, order of n and order of log n. And other are order of log n. If we add one more order of log n, this doesn't matter, this is same. If we had order of n square, then it would have been different, but order of n square by 2, it doesn't matter. So this is the most prominent one, so that is the most important part. So that's why I'm taking order of n as a prominent value for the time complexity analysis, and order of n log n. So these are the 2 things that is really important to find the time complexity of this algorithm. Okay, so no algorithm. But if there are one more thing, if you want to learn more, like for here inside this for loop, we have another for loop. In that case, it is order of n square. If we have another for loop, and it would be n cube, but it is factorial, like 5 factorial. It is 5 times it is like, if we work with 5 factorial, it means that 5 times 4 times 3 times 2 times 1. So in that case, it is order of n factorial. Okay, in that case it is order of n factorial, because we are doing it by multiplying each of the number with this previous number again and again and again. So it is a huge number, 5 factorial. It is a very high amount of time complexity. It is not efficient at all. Then we have the order of 2n. 2n is like, if you have the value n is equals to 2, it would be 4. If it is 3, it would be 8. So this is the power complexity, 2 to the power n complexity, which is again not that great. If n increases up to like 10, it is increases to huge number. So it is not that great. So most of the cases, our n square log n. So most of the cases what we use, order of n. Most of the cases for sorting, order of log n. Most of the cases we do this. And for if we get constant time for O of 1, so that we can just mathematical operation plus minus, popping the last index from the array, all this stuff is order of 1. And then we use like only log n when we divide something like 32 divided by 2, which is 16, and we divide it by 2, which is 8, divided by 2, which is 4. It is dividing it into half, it is reducing into half. Then it is log n. For binary search tree, it is log n, because we're dividing it into different segment. And this is constant time, this is n log n, and this is for O of n, for if we want to iterate all the elements in this array one by one, it is order of n. So these are the stuff that you have to understand. The time complexity and the code samples as well will be given as follows. You will understand the code, how it is working, how you find the mid index, how you iterate over it, how you're gonna find the slice of it, and finally how we gonna get the q1 and q3 so that we can find the interquartile range, and how we have solved this problem. It is actually the most important part. It is not important that you just code along with it and just copy everything. It is not the stuff. It is how you're gonna structure your application, how step by step you are solving this. This is actually this problem solving. This will increase your problem solving ability to a huge amount. So this is the thing I really suggest you guys to really practice on your own, so that you can understand each and every single step and analyze what the thing is going on in this particular code, and each of the line by line. So we have to analyze it in a JavaScript way, in a programmatic way, with your mathematical formula keeping in mind. We have to solve everything here. So thanks all for today. I hope you understand tons of stuff along with the statistics programming, with the JavaScript and time complexity analysis, and how you step by step go through the algorithm one by one, and a full process how you go one by one. So প্রত্যেকটা process আমি আপনাকে ভালো মতো দেখাই দিচ্ছি, so that you can understand the full depth of it, how you're going to go part by part and utilizing it and constant logging it, and just identifying what I'm doing right here, what I have to do here to solve this particular problem. So till then, take care, bye bye. So in the next video with more awesome and beautiful linked list and reader destroy algorithm video. So till then, take care, bye bye. See you in the next video.